So, now graphically also you can prove it graphically. So, now suppose this is x1 and this is x2 and this is, it may not be all positive anything, just for we are representing just 2 point. Now, it is asking that okay, here only y it is taken, not there are no 2 values. So, let us consider only one y is one value. Now, what is x less than equal to x, sorry, okay, this is, there are 2 points y1 and y2 we are proving. I actually thought the last result what we have already proved. So, there are 2 points y1 and y2, and one x is there. Okay. Now, it is asking the probability that this is x will be, so x will be less than equal to x, this x is less than equal to x, that means this area probability of this part, and y will be between y2 and y1. So, this is y2 and this is y1. So, now this value, this is nothing but x y2 and this is nothing but x y1, this point. Now, it is this probability is probability of this region. So, x should be less than equal to small x and y is between y2 and y1, y is less than equal to y2, this region. So, how we will get this region? So, now this is, what is this? The fxy of xy2, fxy of xy2. This is nothing but probability x less than equal to x, y less than equal to y2. So, x less than equal to x is this part. So, suppose I am writing this part, x less than equal to, and y less than equal to y2 is, so whole part it is saying, whole part. Now, this is the probability of x y2, fxy of x. Now, what is fxy of x y1? This is nothing but probability that x less than equal to x, comma y less than equal to y1. So, x less than equal to x is this part and y less than equal to y1 is this part. So, this is the, I am writing this minus. Now, this is plus, actually all plus. So, basically if you are whole, from whole region, if you subtract that part, so then we are getting this part. So, that is the probability that x less than equal to x and y is between y1 and y2. So, that also we have by set theory also we have proved, and also if here we are using graphically also we have represented that. So, this is one of the important properties of the cumulative distribution function. So, this is very similar to the whenever we discussed for univariate random variable also. So, there are only 2 points only, and fx2 probability that x between x2 and x1 is nothing but fx of x2 minus fx of x1, but here 2 point, one coordinate fixing, other coordinate actually we are taking in an interval, and then we are finding the relationship. So, till now it is just a extension, only additional property is that this is 7. So, it is very important. So, any function satisfying all the properties, but not satisfying this property 7. So, then we cannot say it is a cumulative distribution function, joint cumulative distribution function of a bivariate random variable. So, what is this property? If you consider 2 points, so here let us consider 2 points x1 and x2 belongs to R such that x1 is less than x2, and another 2 points y1 and y2. So, another 2 point y1 y2 belongs to R such that y1 is less than y2. Then what is the probability x is less than equal to x2 greater than x1, comma y is less than equal to y2 greater than y1? What will be this probability? So, this probability can be represented like fxy of x2 y2 minus fxy of x1 y2 minus fxy of fxy of x2 y1 plus fxy of x1 y1. So, this is the probability. So, now how we can so this is probability. Suppose here let us consider, so let us first do it because it will be easy to understand. whenever we represent it graphically, this is x1, x2, this is suppose y1, y2. So, we are talking about suppose, so this is the y equal to y1, y equal to y2, and this is, so this is x equal to x1, this is x equal to x2. So, this point is nothing but x2 y2, this point is nothing but x2 y1, this is x1 y1, and this is y1 y2. The probability that x1 less than x1 capital X less than equal to x2 and y1 less than capital Y less than equal to y2, probability will be, see that inside this region x between x1 and x2 and y1 y2. How we will find this region? First, what is this fxy of x2? Fxy of x2 y2, this is nothing but by definition x less than equal to x2, y less than equal to y2. So, x less than equal to x2 and y less than equal to y2, this is the probability of whole this region. So, not only this region, whole region. Now, we do not want probability of whole region, some additional region also we consider in this probability. So, it is actually subtracting some of the value. So, what are those sub value? fxy of x1 y2. So, this is nothing but probability that x less than equal to x1 and y less than equal to y2. So, x less than equal to x1 means this region and y less than equal to y2 means this region. So, we have subtracting this region because it is not, we did not ask for finding this probability, and also we need to subtract this region also. So, that is why it is subtracting fxy of x2 y1. What is this? This is probability that x less than equal to x2 and y less than equal to y1. So, that we have, so x less than equal to x2, x less than equal to x2, x less than equal to x2 means this part, x2 is this, and y less than equal to y1 means, so that means it is subtracting this part also. Now, for subtracting this and this part we subtracted 2 times. So, what is this part? This part is nothing but fxy of x1 y1. So, this is probability that x less than equal to x1 comma y less than equal to y1. So, that we have, so that is why this part we subtracted 2 times. So, here we are adding these terms, that is why this is fxy of x1 y1. So, this part minus this part, again this minus this part plus this part, because it is we have subtracted it 2 times. So, for using this set theory also, you can use set theory also, using set theory also we can prove these things. You can find that what will be the set and how we can represent this, and then suppose if you first find out what will be said that this considering this and fixing y1 y2, and then you can 2 times you can apply the previous what we proved these things. So, you have to apply 2 times, you can check that, then you can also prove it. So, now important part is what we want to say. So, what we found in this property 7, so property 7 it is saying that fx2 fxy of x2 y2 minus fxy of x2 y1 minus fxy of x1 y2 plus fxy of x1 y1, this is nothing but probability that x between x2 and x1 comma y is between y2 and y1. So, that is the property 7 saying. Now, by axiom 1 this probability should be always greater than equal to 0. Hence, any cumulative distribution function, any function bivariate function suppose satisfying properties up to 6 may not satisfy this relationship. So, we have to check that suppose you are considering a function bivariate function that from R2 to R, and that we are thinking that it may be a cumulative distribution function of a bivariate random variable, but it may not be, because it may be satisfying up to 6 properties, but it may not be a cumulative distribution function, it a joint cumulative distribution function of a bivariate random variable, unless it satisfies this relation also. So, we will discuss some of the example where we will face some such kind of cases, where it seems like it is a cumulative distribution function, but it is not a, it cannot be a cumulative distribution function due to these properties. So, now we have already discussed this property, it is called independence. So, what is independence by definition? So, now any event whenever we talk about, suppose let A and B be two events, we say A and B are independent event if probability of A intersection B, this is equal to probability of A into probability of B. Now, how we define two random variables are independent? We already discussed, again we are discussing, it is because independence two events it is okay, but random variable these are functions, these are measurable function. We know the joint cumulative distribution function of two random variables, let x and y be two random variables with the joint cumulative distribution function f x y of x y. This is given by x less than equal to x comma y less than equal to y. Now, this event x less than equal to y, comma it is nothing but y less than equal to y, x less than equal to x is a event intersection. So, this is nothing but in our notation, this is nothing but probability of Ax into By, where Ax is the event for any real number Ax, all S belongs to S such that x of S less than equal to x, and this is a subset of S, and By is the event defined by all S belongs to S such that y of S less than equal to y. Now, X intersection By, so when we will say that this Ax and By events are independent, if Ax intersection By probability of this is equal to probability of Ax into probability of By, then Ax and By are independent events. So, fixing x and y, it may happen that x and by are independent events, but which x, which y we will consider here. So, for f x y we are considering for all real number x and for all real number y. If Ax intersection Bx is equal to P of Ax, P of By for all x y belongs to the real number. That means, what is Ax intersection By? Sorry, this is By. Ax intersection By, what is Ax intersection By? This is nothing but probability of f x y of, so that means Ax intersection By is nothing but x less than equal to x comma y less than equal to y. So, this implies that, and this is nothing but probability that x less than equal to x, this is nothing but probability that y less than equal to y for all x y belongs to R. If this happens, so this implies, so basically we can write this is equivalent to say that, and that equivalent to say that f x y of x y is nothing but, this is called a marginal cumulative distribution function, because here we are considering bivariate random variable and it is a subset of this, a component of this bivariate random variable f y of y for all x y belongs to R. If it satisfies this relationship f x y of x y is equal to f x x into f y y for all x y belongs to real number, then we say that x and y are independent random variable. So, whenever if you can write the joint cumulative distribution function, if you can write it as a product of their marginal cumulative distribution function, then x and y are said to be independent random variable. So, this is the definition. So, let us discuss some examples. So, let us consider So, okay. So, before examples we need to, so because we want to do some of the other computation also, that is why we need to discuss these concepts also. So, how we can find this marginal? So, we are talking that this is the marginal distribution function f x x. Suppose sometimes these distribution functions, joint distribution function are given. So, let f x y is equal to probability of x less than equal to y, is less than equal to y be given to is be known. So, now we want to find the marginal cumulative distribution function, marginal cumulative distribution function of functions of x and y. So, that means we want to find f x of x, that is nothing but probability of x less than equal to x for all x belongs to the real number, and also we want to find f y y y, this is nothing but probability that y less than equal to y for all I belongs to real number. So, suppose joint cumulative distribution functions, this is known. Now, we want to find how we can find that. Okay. So, for finding this, let us consider these things. Limit x goes to infinity f x y of x y. What is this? This is probability that x goes to infinity, probability x less than equal to x, comma y less than equal to y. Now, this is by definition, this is probability that x less than equal to x intersection y less than equal to y, this event. Now, whenever x goes to infinity, as we discussed earlier, so see that y is fixed here, only we are taking x goes to infinity. Whenever x becoming large and large, then this event is nothing but what is x less than equal to x? This is nothing but all s belongs to the set S, x of s less than equal to x. Whenever small x becoming large and large values, then this will all s satisfying this relationship. So, this will be whenever you will take the limit x goes to infinity. So, here we will write the limit x goes to infinity. So, then this set becoming S. So, this is just to intuitive, it is just to understand it. So, we understand that whenever x goes to infinity, this event actually nothing but it is becoming S. So, this is equal to probability that S intersection y less than equal to y. So, this is nothing but probability that y less than equal to y. So, S intersection y less than equal to y, this is nothing but this is equal to y. So, what is this? So, this is f of y y. So, it is by definition f of y y, this is the marginal cumulative distribution function of y. Hence, what we found this result, whenever you are taking the limit of the one variable. So, similarly you can show that limit. So, what we found, x goes to infinity f x y x y, it is nothing but f x of f of y, that we found here. And similarly, if you take the limit y goes to infinity, other coordinate if you take and fixing x on variable, fix one variable and other variable tending to infinity, you will get the marginal distribution function, marginal cumulative distribution function of the variable x. So, that is the method of finding the marginal cumulative distribution function when the joint cumulative distribution function is known to us. So, this is the result here, you take x, y goes to infinity, then this is nothing but x less than equal to x, since the condition is always satisfied, and then similarly y goes to infinity f x y x y, this in f x x. Similarly, if you take x goes to infinity, then you will get f y y. So, this is the concept of marginal, how to find marginal distribution function. Let us discuss some of the examples. So, consider this function f x y equal to 1 minus e to the power of x plus y, e to the power x y, whenever 0 less than equal to x greater than equal to 0 less than infinity, y greater than equal to 0 less than infinity, and 0 otherwise. So, can this function be a joint CDF, joint cumulative distribution function of a bivariate random variable? So, it is asked that can this function be a joint cumulative distribution function of a bivariate random variable? Let us discuss this example. So, this is given. So, let fxy. So, if some function it is given, we do not know it will be a cumulative distribution function. Let f be defined as f of x y, this is equal to 1 minus e to the power of x minus x plus y whenever x is greater than 0 less than infinity, y is greater than 0 less than infinity, 0 otherwise. So, you see that this is the example, f x y is equal to 1 minus e to the power minus x plus y, x greater than equal to 0, y greater than equal to 0, 0 otherwise. So, greater than equal to 0, 0 otherwise. Now, whether it can be a question is whether it can be a cumulative distribution function, joint cumulative distribution function of a bivariate random variable. So, how we can check for checking this, we have to see the properties. So, what are the properties? You can see that. So, it is always between 0 and 1. So, all those properties you have to check. So, let us see that. So, see that because x, whenever x between 0 to infinity, y between 0 to infinity, this is nothing but this is equal to e to the power of minus x plus y. So, here e to the power of minus x plus y always less than equal to 1. So, that is why this will be a this is between always 0 to 1. So, it is goes to 0, e to the power of minus x plus y goes to x goes to 0, actually x being infinity, y goes to infinity, this goes to 0. So, f x y goes to infinity also, and whenever x goes to minus infinity, this is by definition this is becoming 0. And you can see that 1 to 6 all the properties actually it is satisfying, only the 7th property. So, you can remember what are the properties 1 to 6. So, these are the properties. So, x goes to infinity, x goes to minus infinity, it is a right continuous also, and those properties also you can see that it will be satisfying. Only the 7 properties we have to check, because we discussed that this property 7 is very important. So, 7th property says that if you consider 2 real number x1 x2 such that x1 is less than x2 and 2 real number y1 y2 where y1 less than y2. So, then if you find the probability, what is the probability of x less than equal to, so basically finally we will find this probability x less than equal to x2 greater than x1 comma y less than equal to y2 greater than y1. This probability is nothing but this will be the fxy of this we can write x2 y2. If it is a cumulative distribution function, then we can, this is the property actually, y2 minus fxy of x1 x2 y1 fxy of x2 y1 plus fxy on x1 y1. So, we can write this is always greater than equal to 0, and that we have to check here that any x1 x2 and y1 y2, this function also satisfying this relationship, that has to be always greater than equal to 0. So, let us consider any of the numbers. So, any number you can check, or generally you can find this relationship, whether you can theoretically either you can check greater than equal to 0. If it cannot be proved that it is greater than equal to 0 always, then we have to find some example that it is not some, because it will be true for any x1 x2. So, let us consider any x1 x2, suppose y1 is less than 2. So, x1 equals to y1 and x2 is equal to, so let us consider x1 is equal to 1, x2 equal to 2. Here also y1 same we can take, y1 equal to 1, y2 is equal to 2, that actually that also we can take. So, then we have to prove that for this case f of x2 y2, this is nothing but 2 2 minus f of x2 y1 2 1 minus f of x1 y2 plus f of x1 y1. So, what will be the values? So, f of 2 2 this is 1 minus e to the power of minus 2 plus 2, this is nothing but 4 minus 1 minus e to the power of minus 2 minus 1 minus 3 minus 1 minus e to the power of minus 2 minus 1 again 3 plus 1 minus e to the power of minus 2. So, what we are getting finally 1 minus e to the power of minus 4 this. So, all 1 it will be cancelled. So, finally, what we get minus of e to the power of minus 4 minus minus 2 e to the power, because minus we take common, minus 2 e to the power of minus 3, then plus e to the power of minus 2 plus e to the power of minus 2. So, then this can be represented as e to the power of minus 2 whole square minus 2 e to the minus 2 into e to the power of minus 1 plus e to the power of minus 1 whole square. This is nothing but minus of e to the power of minus 2 e to the power of minus 1 whole square. So, see that this is a this is non-zero, and not only that this is square of any this real number positive or negative, but it is square. So, square always positive. So, this is a positive number, and then minus of this positive number, that will be always less than 0. So, for this x1 is equal to 1 and x2 you can try some other values also. I just took some of the values, and then we see that this is less than 0. So, it may be true that any other x1, x2, y1, y2 also you can directly show that this will be less than 0 by this kind of algebra, you can check that. So, that means the property 7 it is not satisfying. So, it is less than 0 means this probability will be less than 0. So, it is not possible, probability is always 0 to 1. So, that is why between 0 to 1. So, that is why it will not be a cumulative distribution function of a bivariate random variable. So, that is one example we discussed. Let us discuss. I hope you are following and you understood it. So, this question was that whether it is asked that whether this function be a joint cumulative distribution function of a bivariate random variable. So, so what we found that it cannot be, because the property 7 not satisfying.